So first, today we're just going to be looking at scatter plots that are already plotted. We're not writing any equations today. We're just looking at how they're correlated, positively, negatively, no correlation, those types of things, which you have talked about. And whether there's causation, meaning does y depend on x? So does your y depend on the x? Is that something that is occurring because of each other? So you're looking at your x and y at intercepts and you're saying, or your x and y axis, and saying, do these labels cause each other in a sense? Okay? So that's kind of what you're going to be doing today, which I think will be the new part for you guys. All right, so let's get started. So a scatter plot is a graph used to determine whether there is a relationship between paired data. So scatter plots, usually what you're going to do here is you're going to have to plot a bunch of points. To determine the relationship. So points are going to be plotted, and then you're going to look at the relationship that occurs. If it's going uphill, it'll be a positive correlation. If it's going downhill, it'll be a negative correlation. If the data just looks like it's scattered everywhere, that's no correlation. I believe that they told you guys to write scattered last year. That's what my kids told me. They say no correlation to you guys. Good, okay, because last year my kids were saying scattered to me, so I just want to make sure we're on the same page. So there's the no correlation as well. So a correlation is a mutual relationship or connection between two things. So as one increases, the other increases. As one decreases, the other decreases. Those are relationships that are occurring. So with a positive correlation, as the x value increases, the y value also increases. X will always increase. You'll always look at it as x increasing. So a perfect positive correlation has a correlation coefficient, which you guys aren't going to really have to deal with this much, but it's good to know what this is. This is called a correlation coefficient of positive 1. So you can have a correlation coefficient from anything between negative 1 and 1. 1 means a strong positive, negative 1 means a strong negative correlation, and 0 means there's no correlation at all. So you can have a correlation anywhere between 0 and 1 when it's positive, or anywhere between negative 1 and 0 if it's negative. So if you're ever reading data for a research paper or anything you have to do, whether it be in high school or college, a lot of times there's statistics in the research papers that you're reading because they took data, and it's good to know what the correlation is because the stronger the correlation, the more accurate the data is. So understanding what that means is really important. So a positive correlation is positive, and closer to 1 it's more perfect. So negative correlation, so this would be like data like this. So if you had a scatter plot that looked something like this, that has a positive correlation. Do you see x is increasing? And y is also increasing. See, they're both going up. So that would be a positive correlation there. So on the other hand, a negative correlation is that as x increases, again, x will always increase, the y value will decrease. So a perfect negative correlation has a correlation coefficient, bless you, of negative 1. So if you don't want to write that again, that's fine, but it means the same thing. So again, negative correlations will be anywhere between negative 1 and 0. So for us, x is still increasing because you're going this way on the x, but you notice your y values are dropping and they're negative, so y is decreasing. That would be a negative correlation. So what questions do you guys have for me so far? Okay, go ahead and get that copied down. Please make sure if you do have questions, you raise your hand and let me know. Otherwise, we will get started. I handed back quizzes yesterday. Yeah, I went over all of them with you guys. We are going to do like a practice performance event with scatter plots on Monday because we're going to spend time the rest of this week doing scatter plots, and it's going to be like a partner thing. On your EOC, you have a performance event. So what that means is it's like a short answer type thing. Typically, it has like a problem, and you have to write the equations from the problem. Usually it's linear. Graph it, fill out tables, and answer some questions. So we're going to kind of make it like that. We're going to try to get some interfacing done on the computers too so that we can have you guys practice because the interfacing for the EOC is terrible. It's like you're using Paint. I don't know why they have not updated it. It is now the year 2016, so I have no clue why they're still using something that is like Paint. So not something we can control. That's the state's thing. All right. So here are just the examples of what we talked about. So a positive correlation is as X increases, Y increases. Positive correlations will have a correlation coefficient between 0 and 1. So they'll have a correlation coefficient between 0 and 1. The stronger the correlation, the closer it is to 1. A negative correlation is as X increases, Y decreases. The correlation coefficient will be between -1 and 0, so it will be R will be greater. Nope. Hey, Sean. Will be less than 0, or R will be greater than -1 or equal to. Thanks for returning that. So R will be between -1 and 0. The closer it is to -1, the more negatively correlated it is. And then a relatively no correlation means that you cannot draw a line through it in any way, shape, or form. So your R would be 0. So the closer to 0 it is, the more that it doesn't have a correlation at all, which means that the data probably does not mean much to you guys at all. So what questions do you guys have so far? Yes, Sarah. So that's not going to be a huge thing. This is just talking about the correlation coefficient. So it's saying the correlation coefficient is between 0 and 1. So like if you were to read a science report and it said that the correlation has a correlation of 0.8, that means it's a positive correlation. So as X increases, Y is also increasing. And it's pretty close to 1, so it's a pretty strong correlation. If it had said like 0.01, that's a pretty weak positive correlation. So that means that those two values really aren't correlated. So if you're looking at data, you're going to say, well, how realistic is this data if it's not really correlated that well? So knowing the correlation coefficient, which you have to do extra math for, so if you take the statistics class that we offer, like your junior or senior year, you'd learn more about the tests that you have to run for the correlation coefficient. We're not doing any of those tests. That's way above Algebra 1. But it's just to understand that, though, that just helps you understand that data is like actually relevant versus not relevant. Does that? You're not going to be doing R on your homework. No, I'm just kind of talking about it. So just so you guys are aware of it, just in case you ever read anything, because I'm sure you'll do some research in English classes or social studies classes or whatever. So that's basically what that's saying, just so you realize that. Okay? Does that help you out at all? All right, next one. Is this your next one? Yeah. So describe the correlation of the graph in the scatter plot. So you always start X to Y. So as X increases, Y does something as well. So in this case, as minutes on the treadmill increase, what happens, Iris? As minutes on the treadmill increase, what happens?
The ounces of water in
Yes. As minutes on a treadmill increases, so your X always increases, the ounces of water in the bottle decrease. So, Carly, is that a negative or a positive correlation? Yeah, this is a negative correlation. Now, is this a pretty strong negative correlation or a pretty weak negative correlation? If you were to draw the line of best fit through this, what do you guys think it would be? This is not something you're going to have to do on your homework. We're just talking about it. Kelly?
Strong.
Right, because if you were to draw the line of best fit through it, which you guys aren't going to do right now, aren't most of those points pretty close to that line? So the correlation has to do with the points being closer and close to the line versus further. So this has a pretty strong correlation because they are close line. We can't come up with that correlation coefficient without running tests and running the formulas for it, but we can have an idea that this is a pretty decently strong correlation, right? All right, so tell me the sentence I should use for the second one there. Alexis, what is the sentence I should say there? You always start with X. Yep, X always increases. What happens? So your calories are going down? They're increasing, good. As minutes on a treadmill increase, calories burned increases. It's going upward. So Jacqueline, negative or positive correlation? This is a positive correlation. Again, if you were to draw a line of best fit, if this is what we were doing and we were actually running a test, this one doesn't seem to have as strong of a correlation as this one, right? They're not as close together. But your points also are not super far away. So there is some sort of a stronger positive correlation, just as not as strong as that negative correlation in the first one. Again, not what you're talking about on your homework. But just want to get you guys to understand, maybe help you understand what that correlation coefficient is. Does that help you understand a little bit better to what the correlation coefficient is talking about? Okay. All right, what questions do you guys have so far before we start talking about causation? Okay, then let's flip when you're ready. All right, so the next thing we're going to talk about is causation. A relationship in which one action or event is direct consequence of the other. Kind of like cause and effect, right? The cause of something and it affects something. So correlation does not imply causation. So just because you have a strong correlation does not mean the two events cause each other, is what this is saying. So just because does not mean the events are caused by each other. So in New York City in the 1980s, they found a strong academic data to support a strong correlation with the amount of crime committed and the amount of ice cream sold by the street vendors. So what they're saying is, as crime increased, the amount of ice cream sold also increased, and there was a strong correlation there. Was this causation? So you're shaking your head, Hannah. Why are you shaking your head? So no, it's not causation. Ice cream and crime are not, so have nothing to do with each other. I like how you said that. For whatever reason. So what this could be is that in the summer, crime tends to increase because it's warmer out, so more people are outside, right? Also in the summer, it's warmer out, so people tend to buy more ice cream. So it might be more of the temperature that's causing, ice cream to increase or crime to increase. Because I don't know if you guys have ever heard, like news people say, as it gets warmer out, the crime becomes more prevalent. Well, people would rather be outside when it's warmer than it's colder. So that's kind of why that happens. So these two are not related to each other, right? But there might be other things that are causing both of them to be increasing, and they just happen to be linked together. They are not caused by each other, as Hannah said. They really have nothing to do with each other. So that's what causation is. So just because there was a strong positive correlation does not mean that there was causation. So what questions do we have so far about causation? All right, then let's look at the next thing. So first we're going to describe the correlation, and then we're going to determine if it's causation. So, describing the correlation means saying, as X increases, what does Y do? That's what that's saying there. So Madison, describe the correlation for me. So as the number of weeks increases, the amount on your paycheck increases. So Morgan, is this a negative or a positive correlation? Good. Avery, do you think this is causation? I think that's definitely, possible. It's not, and so we can't really say that it is causation or is not, but I think that there's a definite chance that it is, right? I mean, we can say that it's not probably more than we can say that it is. So most likely, because the more you work, the more money you'll make. So that's kind of how I want you guys to think about these and answer these. All right, so be careful here. There's years on this, but we're not really talking about the years. The X says fresh lemons imported to the USA from Mexico, and then the Y says the total U.S. highway fatality rate. Can you guys read that on yours at all? Okay, So, Alex, give me the sentence that describes the correlation.
As fresh lemons imported to the USA from Mexico increase, total USA highway fatality rates decrease.
So as fresh lemons imported to imported from Mexico increases, the total U.S. highway fatality rate decreases. So, Spencer, is this a negative or a positive correlation? Good. This is a negative correlation. So, Kaylin, what are your thoughts? Is this causation?
No.
Why not?
Because lemons and highway fatality rates increase.
Right. Why would the imported lemons, have anything to do with the highway fatality rates? So I have no connection to lemon imports. All right. So what questions do you guys have so far? All right, the next example is fine. Then the graph is pretty terrible on that one. Okay, unless it was changed, but I don't think it was. No, it wasn't, and it's not even in order. Okay, there is a correlation between smoking cigarettes and lung cancer. Would this be causation? Vivian, do you think this is causation?
Yeah.
It could be, right? So it could be. But it could also be linked to genetics or something else too. So we can't really say it's ever like a causation, like completely. You're going to have to say most likely or it could be. To genetics or other outside factors. Okay, I'm not going to do the next one because the graph, it doesn't even read correctly. It starts with 35,000, then it goes to 45,000, then it goes to 20,000, then all of a sudden it drops down to 15,000. So it starts increasing and then it decreases, so I'm not very sure how to read that graph correctly, so I don't want you guys to be reading a poor graph. So we're just going to skip that one and go on to the next one. Good, you guys writing that down. It's the same kind of thing. You guys know how to determine positive and negative. You know how to determine correlation at this point. We have one more to do. We'll talk about how to put the graph together. And then we will plot it to kind of get us prepared for tomorrow's lesson. Okay, so it says City, latitude, and average temperature. The two variables are what? What are our two variables? Because this table has three things in it. So what are my two variables, Jenny?
Latitude and average ambient temperature.
Good. And we're going to determine how they're correlated. So really these are all in the first quadrant. So I'm going to make my graph all in the first quadrant. You guys are going to have to determine that. So, oops, I didn't want that one. Draw a line here. And draw a line here. And then we're just going to have to scale this. So we only break one axis. So I would think that the temperature depends on the latitude. So we're going to call this latitude degrees north, because the higher, the farther away you are from the equator, usually the cooler it is, right? And temperature, degrees Fahrenheit. Okay, so we're only can do a break in one graph, side of the graph, so we can't, I'm not going to break the x, I could break the y. Do you know what a break in the graph is? Do you know what this is? Have you seen that before? That just means you're not starting at like the 0. So I'm going to start with my y's. My lowest one is 39.4, right? So if I start here at 39, I will be able to get that in there. What's my highest? 82.6, is that what it is? So I got to figure out what I can count by. I'm going to try counting by threes and see what goes. Sometimes I erase a lot. I don't know about you guys when you're doing this. So I'm counting by 3 right now. So I am counting by 3. I need to get to 82. And I don't think it's going to happen. Yeah, that's not going to happen. Okay? So then I erase. And I try again. What are you counting by? Anybody get something that worked? I could try 4s now. So let's try 4. So that'd be 39, so that's 43. 47. 51. 55. 59. 63. 67. 71. 75. 79. Good, we're going to make it this time. 83, right? Hopefully I counted correctly. So that works for the temperature. This one I'm going to have to count normally. So let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So let's just count by 5s on the bottom. And then you guys can start plotting your points. So go ahead and start plotting your points from your table, and then we'll look at the correlation. So Bangkok is 13.7. Just do as best as you can to get in the right location. So 30, 71.4. If you don't know how to plot points, please let me know. I know I'm not explaining it. I'm just assuming that you guys know how to plot points. So something of that nature. Get the points plotted, and then you guys can determine what kind of correlation you guys think it is. Katie, what kind of correlation are you seeing as you're plotting it?
Negative.
Good. So it is negatively correlated.